What are the 7 main features of Node? This is a very important question. We already have many technologies for creating the web applications like Java, .NET, etc. Right? Then why Node is the best choice now? That is because of the Node's features only, right? So here are the 7 features. Node, like JavaScript, is a single threaded. The program, second is for program in Node executes in a asynchronous way. Then Node applications are event driven. Then Node uses V8 JavaScript engine, which you already know. Then Node is cross platform, and therefore it feature can run on can any operating system, right? Then Node has npm, Node Package Manager, which manage all its dependencies. Finally, Node has real-time capabilities, meaning it is very good for handling bi-directional communication. Bi-directional communication like chat application, gaming application, where user basically interact in real time, right? Great. Now, in upcoming question, I will explain all the features one by one, and this I will show and I will also show the advantages, and I will show how those advantages are basically coming from these features only. Okay, so that we will see in upcoming questions. What is single-threaded programming? Let's quickly understand. We already know first user from the browser send the request to the client and then to the server side, right? Now inside the server, suppose the request has to perform 5 independent tasks. For that, in the case of normal programming, a single thread will be created like this. Then first this thread T1 will start the task 1. Now listen carefully. Thread T1 now will wait until task 1 is completed. Okay, T1 is waiting. Once task 1 is completed, T1 will go to the task 2 and start it. And then again thread T1 will wait until the task 2 is completed. Then same for task 3, and finally the completion for task 4. And after completion, like for after the task 4, the thread T1 will inform the API about the completion of all the tasks. Now this is simple, straightforward, single threaded programming, and it's a synchronous programming because here tasks are executing one by one and one task is waiting for the previous tasks to be completed, right? But in Node or JavaScript, we can achieve asynchronous programming even with the single thread, and that I will explain you in the upcoming question. What is synchronous programming? Now many have confusions between synchronous and single thread programming. For example, here is the single threaded execution which I previously explained. Remember, single threaded programming means we are talking about single thread. Okay, a single thread is responsible for starting the task. Now with a single thread we can achieve both synchronous and asynchronous operations. Okay, here by using the single thread we are doing synchronous operations, because synchronous programming means each task should be performed one after the other. Okay, that's what we are doing here, right? So that is synchronous programming. The disadvantage of this synchronous programming approach is performance. This synchronous approach will take more time. See, a total like it's 10, then 8, 4, 5. Total 27 seconds will be taken to execute all the tasks. And one more problem is there. This synchronous approach is a blocking approach, because here until task 1 is completed, task 2 has to wait, right? So task 1 is like a blocker for the tasks 2. So that is the blocking thing. Now in order to perform the task concurrently for improving the time performance and for a non-blocking approach, we will see the asynchronous approach programming in the upcoming question. By using what? Yes, node. Okay, which actually happened actually in Node. Great. So finally here I have written the simplest definition for the synchronous programming, which I already explained, and also the difference between synchronous and single thread programming for later revision purpose. What is multi-threaded programming? Let's quickly understand multi-threaded programming so that we know the difference between single thread and multi-threaded. So here the user and client side send the request to the server, you already know. Then the server will first create a thread T1 which will start this task 1. Okay, now listen carefully. In a multi-threaded approach, when one thread starts one task and then it sees another task after that, then immediately another new thread T2 will be created, and that T2 will start the tasks too. Okay, so while the T1 thread is waiting for task 1 to be completed, in parallel the new thread T2 will start task 2, and therefore both tasks are being executed in parallel. Similarly, when T2 start task 2, then for the next task 3, another T3 is created which will start task 3, and then T4 thread is created for task 4. Finally, you can see how different tasks have different threads in a multi-threaded environment. This approach is very good for CPU intensive tasks where many tasks has to be performed parallelly. If you remember our computer processor, and it has multiple cores, right? So having more cores means they are much better for multi-threaded programming applications. Okay, for heavy desktop software it is very good, this multi-threading approach. But for internet APIs, this multi-threaded approach can be a problem because multiple threads can create deadlock problems if not properly handled. That's why we prefer a single threaded asynchronous approach for JavaScript and Node applications. What is asynchronous programming? Now this is our main target, and this is what we will use in our Node applications. Previously we saw how synchronous programming is not good for performance, and also it's a blocking approach. That's also something we will solve here. In Node.js, suppose a request has to complete 4 tasks, okay, like this. Then first a single thread is created which will initiate the task 1, okay. Now listen carefully. Now this thread T1 will not wait for this task 1 to be completed, will not wait, okay. Instead, after initiating task 1, this thread T1 will immediately jump onto to initiate or start the next task 2. Then after initiating task 2, T1 jumps on to initiate task 3 and then task 4. Great. Now you have the most important point about single-threaded asynchronous operations. And the point is that our single thread T1 is just initiating the task and not waiting for its completion, right? So now you can imagine how in this case our tasks are running concurrently. And if you remember, in synchronous way, the total time was 10 plus 8 plus 5 plus 4 plus 5, right? 27 seconds total, which is the least time. But now the total time taken can be 10 seconds in the best case, but time can be something more. It depends on your hardware also. Okay, but in any case, it will be better than the synchronous operation. So that was, we solved the first problem, the time and performance problem. Another problem was the blocking issue. So here task 1, 2, 3, 4 while executing are not blocking the execution of the next task. Okay, so when task 1 is executing, tasks 2 in parallel concurrently can also execute. Okay, so therefore it's a non-blocking way, the synchronous approach. All right, that's all about asynchronous programming. Now you might ask one more question, like when task 1 is executing independently, then this thread T1 is busy in starting the other tasks, right? It is doing its work. So how the system will know when the task 1 is finished? So there comes the role of the events in Node. Whenever any task is completed or finished, it will raise an event. Okay, so then that event will immediately listened or heard by our thread T1, and our thread will immediately stop whatever it is doing at that point of time. Okay, and what T1 will do? On priority basis, it will immediately report the task completion to the source. And then again, T1 will resume whatever it was doing earlier. So that's why we also call Node.js has an asynchronous programming approach and also the event-driven architecture. Okay. In upcoming question, I will discuss more about events. Before that, here are some steps for the execution of asynchronous operations using a single thread in a node, which I already explained, writing it down for quick revision later from the book. And here is the simplest and most complete definition of asynchronous. In Node, asynchronous flow can be achieved by its single-threaded, non-blocking, and event-driven architecture. Remember in JavaScript also, by using the async await or promises, you can achieve this asynchronous programming. Okay. What is the difference between synchronous and asynchronous programming? I already explained them separately, but here I have also written down the differences. It's point by point, and you can see I have also pointed out the advantages of the asynchronous programming over the synchronous programming. So if you understand synchronous asynchronous programming, then these differences and advantages are very easy to understand. You can either pause the video and read it, or later you can revise the differences from the book. That's the quick answer of this question. What are events, event emitter, event queue, event loop, and event driven in Node? All right, this question will clear up all your concepts about the events in Node. First of all, what is an event? An event is like a signal that something has happened in a program, like a notification, like a action has happened. Like if you remember, we have those click events in the UI, right? So now these events or notification must have some source from where these events are originated, right? So these sources are called event emitters, who generate the events like this event 1 and event 2. All generated events are then stored in a queue, okay, which we call what? Event queue in Node. Okay, clear until now? Then Node will pick one event at a time, and the event handler, or we can also say it event listener, will perform the code as per the event requirement. So basically here you will write the code that how you want to handle the event in your application. Okay, so it's nothing like event handler is nothing but it's a function, okay, so written by us. Okay, in case of threads, it is written by the node to how to handle it asynchronously inside the node runtime environment. Okay, all right, after that the next event will be picked by the event handler from the event queue, and it goes on like next event, so on so on and so on. So the picking up of these events like this one by one from the event queue in order in the same order is called the event loop. Okay, so great. That's the whole story. Easy, right? About how the events are originated and how they processed. And also here I have written the simplest and the most easy to understand definitions of events, event emitters, event queues, event handlers, and event loops. Okay, all I already explained. And finally we have this event driven architecture. Event-driven architecture is a combination of all of the above. What does it mean? It means operations in Node are driven by or based on the events only. Okay, driven by events. So that's why we call Node as the event-driven architecture. Great, that's the answer to this question. What are the main features and advantages of Node? So in interviews, many times we directly started speaking about the advantages of Node without relating them with the features. For a great answer, you should know that from where the advantages are coming. Okay, every advantage in any technology comes from some features of that technology, right? So therefore, if we are able to relate both features and advantage, then it's a great answer, and you will also feel it after listening this answer. Here are the 5 features you already know, right? Now, Node.js has asynchronous operation. It has a Google Chrome V8 JS engine. It has event-driven architecture. It's a cross-platform, and it uses the JavaScript language. Okay, so these are the features. Now, here are the advantage we get from these features. First, because of asynchronous, Node.js can enable handling multiple concurrent requests and can do non-blocking execution of threads, right? Then second, because of Node it is built in V8 JavaScript engine from Google Chrome. Therefore, Node.js execute code very fast, very quickly. Okay, JavaScript engine only executes your JavaScript code, right? Next advantage is, because Node is event-driven architecture, therefore it is very efficient in handling asynchronous operations and events. Okay, handling events will be very easy. Because threads will respond as per the events generated, if you remember the asynchronous operations, right? Also in the chat applications, gaming applications, why events are important? Because there are too many events generated when bi-directional communication in chat applications. So that will be very easy, and then Node will be a great choice. Okay. Next is cross-platform. It supports deployment on various operating systems like Windows, Linux, and which basically enhancing the flexibility of your application so that it can be hosted in any operating system. Then next advantage is, as we code in the JavaScript language only in Node, so basically there is no need to learn a new programming language. Okay, so that's also an advantage. Same language can be used for the client side and for the server side development also, right? Then last, and because of all of the above feature, Node is suitable for building scalable applications that can handle increased loads. Scalable means, so suppose if tomorrow when your application will grow after 2 year, 3 year, it will become bigger and bigger. And then if it is developed in Node, your application, then it will be very easy to grow it, to scale it, and add more features to it. So that is scalability. All right, that's the whole story of the features and the advantages of Node. What are the disadvantages of Node? When to use and when not to use Node. So everything of course has some disadvantages also in this world. So does the Node also have something? You already know when to use Node for your project, right? It's ideal for real-time applications like chat application, online gaming, collaborative tools because of its event-driven architecture. Then also it is excellent for building lightweight and scalable REST APIs that handles a large number of concurrent requests or connections. Okay, then also it's a great choice for microservices based architecture because it have the modular and scalable system. So modular approach is there in the Node also. Now the main question here is, when not to use Node? So you should not use Node in project that demand CPU intensive task. For example, video processing, For example, some software which require heavy algorithms to be executed, which required multi-threading. So because in that case, multi-threaded technologies will be a great choice, not a single thread technology like Node. Okay, because multi-thread can perform multiple tasks, multiple core, they can use the heavy servers and that. So that's the answer of this question. You should not use Node for CPU intensive task.